and then we'll get back into Unit 2. Before I start going over the assignment at the end of the Unit 1 packet, which begins on page 21, let me just make sure you all see here. These are the items you need to make sure you have with you for tomorrow's test. I don't loan them out, and you're not allowed to share. You need to make sure you have a pen, black or blue ink, a pencil, a ruler. You need your own metric ruler so you can measure things on the test. And you also need a calculator to do the calculations that are required on the test. Okay, any questions about materials? All we're doing tomorrow, our single period, is taking the test. That's it. So that's all you need to bring with you. You don't need to bring any other physics stuff. Just a pen, a pencil, a ruler, and a calculator. Remember, the only time I told you need a pen in this class is for tests. So tomorrow, that's why you need it. Pencil will be for any graph I ask you to construct or drawing that you have to make. That's the only reason you use a pencil. Okay? Questions? All right, let's get through the Unit 1 review. If you could all please turn to page 21 in your Unit 1 packet. Please also have out your notebook in case you need to take some notes on anything we're going over that you don't understand to help you prepare for tomorrow's test. You should also have out your pencil, obviously, so you can write things down, and a ruler because there were some measuring questions on this test. Your calculator, so if you have to recalculate something, and several questions on here did require the use of your reference table, so you'll want to make sure you have that out right now as well. I'm planning to give you answers to everything first. And then once I've given you the answers to the entire review packet, if you have questions, ask them then. But save your questions to the end. All right, y'all set? Page 21? Okay. Here we go. Number 1. They asked you to label the targets. Number 1, the first target you should have labeled C. The second target you should have labeled A. The third is D. And the fourth is B. Number 2, measure each of these. And how many significant figures are in each measurement that you made? So the first measurement for this pencil from the end of the eraser to the tip is 6.40 centimeters. That's the accepted answer. The first thing I'm looking for, did you measure out to the 100th place? So if you said 6.4 centimeters, that's going to be marked wrong immediately because you didn't measure with the correct precision. But I'm going to give you 0.2 of a centimeter leeway, which means I'll allow anything between 6.20 and 6.60 centimeters. Those measurements all have 3 significant digits. Letter B, measuring the length of this pen from the end of it to the very tip up here. It's 10.25 centimeters. Again, I expect to see a measurement made out to the 100th place. So if you didn't measure to the 100th place, it would be marked wrong because you didn't know how to measure correctly with a ruler. Secondly, it's got to be within 0.2 of this accepted value. So anything between 10.05 centimeters and 10.45 centimeters would be accepted, provided it went to the correct precision, and it should have 4 significant digits. Number 3A, this measurement has 2 significant figures, and when I put it into scientific notation, retaining the 2 significant figures, it becomes 3.2 times 10 to the negative 3rd power, and of course you have to follow it with the unit, which is millimeters. Make sure that millimeter unit is on your answer. Letter B, this measurement has 3 significant figures, and it is 3.81 times 10 to the 4th power kilograms. C has 3 significant figures. Its measurement in scientific notation is 7.01 times 10 to the negative 4th power. And of course, you need the unit at the end, which is seconds. D is 4 significant figures. And in scientific notation, we would write it as 3.600 times 10 to the 1st power meter per second, retaining the 4 significant figures. E has 1 significant figure. And in scientific notation, you should have written 4 times 10 to the 2nd power, and that is measured in capital N. Number 4, carry out these unit conversions. So we're going to use factor label method. The first thing we have to do is look up the conversions for milli and kilo, those 2 prefixes. According to your reference table, milli is 10 to the negative 3rd power, and kilo is 10 to the 3rd power. Could you have to show the factor label process to get this? Yeah, you might be asked to do that. So let's make sure you know how to do that correctly. You start by taking the given measurement and you put it over 1. So 5.5 milliseconds over 1. Now, milli is not in our answer, so we have to multiply by this conversion factor so the milli cancels, which means milli goes in the denominator. And the equivalent power of 10, which is 10 to the negative 3, or 1 times 10 to the negative 3 goes in the numerator. Now I have to multiply the remaining second by the kilo, so the kilo's got to go in the top of the next fraction, and therefore the 1 times 10 to the third power goes in the denominator. Now you multiply and divide this through, which gives you a final answer of 5.5 times 10 to the negative 6th power kiloseconds. All right, let's go to 4B. Looking this one up, I have the prefixes nano and giga, so I looked those up on my reference table. Nano is 10 to the negative 9th power. Yeah, that's part of the process. Remember, save your questions for the end. So nano is 10 to the negative 9, and giga is 10 to the 9th power. So when we set this up, we start off with 81 nanometers over 1. We now need to cancel out the nano, so nano goes in the denominator, and the 1 times 10 to the negative 9 would go in the numerator. And then in the next fraction, giga would go in the top, and 10 to the 9th power, or 1 times 10 to the 9th power, goes in the denominator. Now, if you do the calculator work correctly, you'll get 8.1 times 10 to the negative 17th power gigameters. Letter C, we have 12 decigrams. I want to know how many picograms that is. You're not going to need your Chromebook at all today. Yeah, it's just taking away your time from review right now. So we have deci, which is 10 to the negative 1 power, and pico, which is 10 to the negative 12th power. So we want to get rid of the deci. So we're going to start by putting 12 decigrams over 1. The deci goes in the denominator, 10 to the negative 1, or 1 times 10 to the negative 1 in the numerator. And then the pico in the top and 10 to the negative 12 in the bottom. We multiply and divide accordingly, which gives us 1.2 times 10 to the 12th power picograms. All right, number 5, we have to do all the algebraic manipulations to solve for the variable x. In this first equation, we have PES is half of k of times x squared. So the first thing I have to do is get the half of k out of here and move it to the left. Since these are all being multiplied, we're going to divide by half of k on both sides. So that leaves us with the equation that PES over half of k is equal to x squared. Now I have to take the square root of both sides, which gives me a final equation for x, which is the square root of PES over half of k, or if you prefer, when you divide by a half, that's the same as multiplying by 2. You could have said the square root of 2 times PES over k. Either one. Letter B, we have f is negative kx. I want the x by itself, which means I have to get rid of the negative k. These are multiplying the x. So we're going to divide by negative k on both sides, which gives us f over negative k is equal to x. Letter C, we have 3 plus x over y squared is equal to z times y squared. The first thing I have to do, is equal to z. We have to multiply both sides by y squared. To get the y squared out of the denominator, undo that division, which gives us 3 plus x is equal to z times y squared. Now what you're going to do is subtract the 3 from both sides, which leaves you with x is equal to z times y squared minus 3. Letter D, we have y squared over 3 plus x is equal to z. The first thing I have to do is cross multiply because my x is in the denominator. So that means I end up with y squared is z times the quantity 3 plus x. Now I have to divide both sides by the z. So that way I end up with y squared over z is 3 plus x. Now I have to subtract 3 from both sides, which gives me y squared over z minus 3 is equal to x. All right, let's now try some guess method problems. Number 6, you should have started by circling 4m over s and 12 kg m over s and underlined the word mass. This is all mechanics stuff based on the wording on your reference table. So when I list out my givens, I should have said that V equals 4m over s and P is equal to 12 kg m over s. My unknown is lowercase m. The equation you should have selected is P equals mv, but now you have to move it around for m. So m is equal to P over v. Now we can plug in the given measurements and their units. So we have 12 kg m over s all over 4 m over s. So now I see the m over s in both the numerator and denominator. So those would cancel, leaving us with a numerical answer with one significant figure of 3 kg. Now, the dimensional analysis step is done for the equation that we plugged into, m equals P over v. So the unit I had for m was kg. The unit I have for P is kg m over s. And the unit I have for v is m over s. I see that those m over s's are going to cancel, leaving me with a kg on both sides, so that checks. Number 7, you should have circled 8.5 m over s, 4s, and 6 m over s. You should have underlined the word acceleration. Again, this is mechanics, and we should have been able to identify that VI is 6 m over s, VF is 8.5 m over s, and T is 4s. The unknown letter is A. So there are 2 equations you could have picked. One of the 2 is A is change in V over T, which becomes VF minus VI over T, or you could have used VF as VI plus AT. Either way, you end up with A is VF minus VI over T. We're now going to plug into that, which gives me 8.5 m over s minus 6 m over s all over 4s. I do the subtraction first due to order of operations, so that gives me 2.5 m over s over 4s. We do our sig figs at the very end. So when I divide this out, I'm going to round my answer to one significant figure because of the 4s, which means my final answer should be 0.6 m over s, or 0.6 m over s squared. Now we do our dimensional analysis on A is change in V over T. A we said was an m over s. The change in V is an m over s, and the T is an s. So the left and right check, and that's a good dimensional analysis. Last guess method problem is number 8. You should have circled 0.5 capital A, 4.5 ohms, and underlined the word power. This comes from the electricity page of your reference table. And when I list my givens, I should have said that the 0.5A was equal to the I, capital I, and capital R was equal to the 4.5 ohms. My unknown was capital P. Based on the equations on page 4 of the reference table, the equation that has those variables is P equals I squared times R. We're now going to plug into that. So that is 0.5 capital A, that quantity squared, times the 4.5 ohms. And when I look at this, I see the 0.5 has only one significant figure, which means my final answer will get rounded to one significant figure, which means my final answer is 1. Now, the units I'm coming up with are A squared times ohms. Now, the check. I'm going to check the units on P equals I squared R. So I just said that P was in capital A squared times ohms. Capital I, we said, was measured in capital A, which has to get squared, and R, we said, was measured in ohms. And notice that now the left and right side are equal, so that does check. All right, the last page deals with the graph. The first thing you had to do in question 9 was construct the graph. Let's just go over what the graph should look like, starting with a title. Do you have a title on the graph? If not, that would cost you points on tomorrow's test. The correct title is velocity versus time, not time versus velocity. So you want to make sure you have those in the correct order. You should have listed a label on the y-axis, velocity in m/s. You should have labeled the x-axis time in seconds. Now, remember, you want to spread this out as much as you can, but pick a scale that is easy to count by with the lines. So I did every 5 lines on the x-axis was 1 second. That gets me all the way to 5 seconds on the horizontal axis. Did you have to do that? No, but I would be checking your scale to make sure your scale is appropriate and uniform. Then I need to make sure on the y-axis that I can get to at least a value of 110, if not more. So what I did was I got all the way to 200. I want to try to spread it out as much as I can and go beyond the 110. So by picking every line as 10, that gets me to the 110 and beyond, 200. So I just labeled every other line, so 0, 20, 40, 60, 80, and so forth. That got me all the way to 200. I then plotted my data points with little X's, as you can see here. And then in part B, it asks you to draw the line of best fit, so you can see the best fit line on there. You should not have connected the dots. Likewise, if you connected the first point with the last point, that is not best fit. That would lose credit also. The line should go in the middle, so we have some points above the line and some below, but some of them are right on. You want all 3 characteristics. Some of the points right on the line, as many as possible, with as few off the line. Now, part A asks you for the relationship. Let's ask another question before that. If I asked you for the shape of that line, what would you have said? You would have said diagonal line. The shape of that graph is diagonal line. What is the relationship? Direct. So that is your answer to part A. You would have said direct. Now, in part B, it wants you to find the slope of the line that you have. Remember, the process for doing this is to circle 2 points on the line that you're going to use. I'm going to use this point that the graph starts at, and then I want another point out here where grid lines intersect. I'm going to choose that point right there. That is point 2 in my calculation. If I had used the data for this point right here that I'm pointing to, would that be correct? No, why not? It's not on the line. You would lose full credit on this question because the question would not be calculate the slope of the points. The question is find the slope of your line. If the point isn't on the line, you cannot use it. Okay? That's why I'm using a point like that and a point like that. Those 2 are right on the line. Now I'm going to list my givens like we did when we practiced this. What are the coordinates of those points? Point 1 for me had coordinates of 0 seconds and 10 meters per second. And my second point had coordinates of 2.8 seconds and 70 meters per second. Do those have to be your coordinates? No. This is an example of what you needed to do. Those were the 2 points that I circled. So whatever points you circled, as long as they're on the line and you're reading those coordinates correctly with the units attached, you're okay. Now, what is my unknown? It's slope, lowercase m. You need to know the slope formula for tomorrow. It will not be given to you. The slope is y2 minus y1 over x2 minus x1. If you tell me tomorrow for the equation, you just write that. If you just show y2 minus y1 over x2 minus x1, that's not an equation. You don't get credit for that. An equation has to have a left side and an equal sign and a right side. So make sure you show me both. Okay. I'm just warning you, that's a common mistake on the test when I ask you to find a slope and then you don't show the correct full equation. Equation has to have the left and a right side all year.
You can have M or slope, right?
Yeah, and I'd actually prefer you write the word slope like we did in class. Just my key right now has an M. So I'm going to plug in the points with their coordinates. The numerator ends up giving me positive 60 meters per second, and the denominator ends up giving me 2.8 seconds. Notice that now this is where I look at my sig figs to determine the slope value. The numerator has only one significant figure. So that means my answer will have only one significant figure. So when I round that, I get positive 20 m over s over s. Joshua, you had a question? No, remember they can be little x's, little pluses, little dots, or little dots with little circles around them. And those dots, if you use a dot, it's got to be itty bitty, but big enough I can still see it. Yes, then you can use it because it's on the line. Okay. And then part C wants the equation for this line of best fit. So we all should have started with y equals mx plus b, and now you're going to change it out. So the y should have been changed to the word velocity. The m should have been changed to whatever you calculated for your slope. Plug it in. Positive 20 m over s over s. The x should have been changed to the word time. And b is the y-intercept from the graph. My y-intercept, when I read it, it's going right through the 10 meter per second value. So that is my y-intercept, 10 meters per second. Okay, anything on this that you want to go over, Shane? On the slope, yeah, because that has a meaning in physics. Dan?
For number 4D.
For B or D? B. Yep, this conversion.
Yeah, I thought you're not supposed to use scientific notation unless you question.
Well, when prefixes are scientific notation.
Oh.
So these will always end up in scientific
Or it
notation.
would be wrong if you like bug level decimal.
Well, this one, you want to write out 16 zeros before the 8? No. So don't. Okay. That's it.
For the guess method, do we have to do the check at the end of the test?
So here's how the guess method questions, the directions will be worded. I'm going to write this down. You may want to write this down as well. On all of the constructed response part of the test, there's two parts. Part 1 is multiple choice. Part 2 is constructed response. Every unit test you take will have 10 multiple choice, worth 50 points. So each multiple choice question is 5 points. That gives you half your test grade for the multiple choice. The constructed response is the other 50 points. And I can't tell you how many constructed response there are. There's however many there needs to be in order to get to 50 points. But on a guess method problem, it would say something like this at the end of the question. Show all work, including. Now, I'm just going to put some dots for now, because anything that shows up after the word including is what I'm grading. And that's what you have to show, which means if it's not after the word including, am I going to grade it? No. Okay. So for an example, let me show you what the wording, if question 6 were on your test tomorrow, this is how I would phrase the directions for that question. It would have said, show all work, including the givens, the unknown, the equation, the algebraic manipulation, substitution, and the substitution with units. Express your final answer with appropriate units and significant digits. Okay, that is how it would be worded. Do you see a thing here with dimensional analysis? Dimensional analysis questions are generally separate problems. And those questions would be something like show, or using dimensional analysis. I have to remember how we word them. Using dimensional analysis, show that the units of m equal the units of P divided by V. That is what we did for this one. We showed that the units of M equal the units of P. The units of them are, so then you're just doing the proof. You set up one equaling the other. That's how it would be worded if it's a dimensional analysis problem. And I would actually say, I would use that term, dimensional analysis, in the question if I want you to do the check. So with this one, since we do not see dimensional analysis in the including piece of things, you don't have to do the check. Now, if you did a check, you're not going to lose credit in that problem. But here's what ends up happening. If you spend time showing me stuff that isn't going to be graded, that takes away time you have left to do the other stuff that is going to be graded. And if you run out of time on the test, that ends up overall lowering your grade because you can't get those other questions done. Do you understand what I'm saying? Does that make sense? You have to be a good test taker to read the directions on a question to figure out where you're going to spend your time. And don't waste your time doing things that are not going to be graded. You follow? Because if you run out of time, oh well, you're not coming back later in the day to finish the test. You got the 40-minute class period and that's it. The test is designed to be done in a 40-minute class period, which means if you can't get it done in 40 minutes, it means that you didn't know the material well enough to be able to be successful on the test. You follow what I'm saying? It's just kids who know what they're doing can get this test done very quickly and easily because they've prepared themselves. They kind of know what's already going to be there because they did this. And they've been studying all along, making sure they know what they're doing. If that hasn't been you and you don't finish, well, okay, you got an opportunity to correct your multiple choice questions for half credit back, but not the constructed response. And then your next opportunity to show me that you're learning from your mistakes is with your second unit test. And hopefully we can try to correct those study behaviors before that next test. Okay. Other things you want to ask about? Yes, Mariah?
So I have two questions.
Yep.
On number 24 with the graph, I went up by
So wait a second, not what, 24?
like page 24 on the
Oh, page 24. Okay. I was like, number 24. I don't have 24 questions in the review. Question 9. Yeah. Okay. What's up on the graph?
So I went up by 5.5, that got me to 110 on the y-axis.
Yeah, that's a tricky scale to use.
So,
Because then how do you subdivide 5.5 in a block?
so since I chose that.
Yeah.
And my line goes all the way up, like through that last point, 110. Would that be wrong since
No.
it's not been fit?
That's it. What I'd have to do is look at your line because then this is down here is probably not right on it either.
Right.
Okay.
And then I have another question about so page 21.
Yeah.
Number 2.
Yep.
Can you just like explain the significant figures a little bit more?
Yeah. Okay. So remember we have the Atlantic Pacific. This measurement has a decimal point that is clearly present. So we're going to count this way, starting with the first non-zero that we encounter. Non-zero means not zero. What's the first digit you read off in this direction that is not a zero? The 6. And that means you're going to start counting with the 6 until you get all the way to the end of the number. So 1, 2, 3. This one is also present. So we count this way, going from the Pacific towards the Atlantic. What's the first digit you encounter that is not a 0 when you read in that direction? The the 1. So when I count them, I count 1, 2, 3, 4, giving me 4 sig figs.
So the plus, that's just the margin.
This is the margin of error that I allow you to have. So when I'm grading your response, if you said 6.38 centimeters, that's within this tolerance, you get the credit. If you had said 6.61 centimeters, that is outside this tolerance, and you do not get credit. Follow? That's what this is for. So you don't write this. When you're taking the test, you just write that, 6.40 cm. Then this is on my key, so I know what the margin of error is that I'm allowing. Okay, that's how we write it in our rubric, in our answer key. Anything else? You sure? You have nothing else you want to ask before tomorrow's test? Okay, what materials do you have to bring again for tomorrow's test? Who can tell me something they have to bring for tomorrow's test? Joshua. A pencil. Yep, because there is going to be a graph. Yep. Eric? A pen, because that's everything else that you're writing down on your answer sheet will be in pen. Mia? A calculator, scientific or graphing, doesn't matter to me. What else? A ruler. That's it. Pen, pencil, ruler, calculator. You supply your own. You do not get to borrow anybody's. I give you a clean copy. So that means those 2 equations that I told you had to memorize for Unit 1, percent error and slope. Guess when now you're being tested on knowing those equations? Mañana. In class here tomorrow. Yeah. No. And that you would do in your test booklet. So you can write all over your test booklet, like on a Regents exam. You can write all over the exam booklet, but all that gets graded is your final answer sheet. I will never look at your test booklet. And I'll explain that tomorrow once you sat down and I give it out. Because it's the first time you're taking my tests. I want you to understand they're all written the same way, same process. Nicole?
May you go over accuracy and precision?
Sure. All right. So when we talk about accuracy, we're talking about how close a measurement is to the accepted value. And percent error is one way we can determine how accurate something is. The lower the percent error, the more accurate something is. When I talk about precision, I'm talking about the repeatability of a measurement or the exactness of the measurement. So this is usually determined by looking at the number of decimal places to the right of the decimal point. So for example, 4.2 cm is less precise than 4.21 cm. This is more precise because it's going to the 100th place. That one only went to the 10th place. Eric?
So it's like the value we're trying to get would be like 0.42, like 4.21 or precisely 0.4211.
I'm sorry. Read those numbers off to me again.
Like if you're trying to get like 4.2,
So this is the accepted value.
Yeah.
Okay.
And 4.21 is more precise than 4.211.
No, this is more precise than that.
So we're not trying to get the accepted value. We're just trying to.
Precision has nothing to do with the accepted value. You don't look at that at all. Not at all. All you do is you look at these. Which one has more decimal places to the right of the point? This one does. This is more precise than that. But which one is more accurate? This one, because it's closer to that. Okay. Anything else? Okay. Then let's continue with Unit 2. Could you please pull out your notes from yesterday for Unit 2? Unit 2 in your notebook. Remember, I'm writing things down as we do this. Today for Unit 2, you're going to need the following things besides your notebook and a pencil. You will need a calculator. You're going to need your reference table. And then you'll need your Unit 2 packet. So let's get those items out. Unit 1. Self set up here. Bear with me, please. All right, so if I remember correctly, and I think I do because I have everything written down that we're working on, this is where we left off in our notes, talking about different ways to define direction. Okay, I'll grab my pencil again. So when we talk about direction, and we have to talk about direction because lots of measurements in physics are vector quantities that we were talking about yesterday. The first example we have of a vector is the position of something. How far are we to the right of the origin? How far up above the origin? How far below it? And so forth. There are three different ways we can specify the direction of an object. The first way we can specify direction is by using words. And when I say using words, I mean things like saying right, actually spelling out right or left, up or down, in or out, that would be three-dimensional space, forward or backward, north or south, east or west. And then I'm sure you may be able to think of others. Second way we can do this is by using a sign, meaning a positive or a negative in front of a value. Generally, when we use positive, that either means right or up, depending on whether I'm talking about X direction or Y direction. Bless you. Negative would therefore imply either left or down. Signs are not as specific as words because I don't know whether it's right or up if I put a positive in front of something. The third way we can specify a direction is by using an angle measure. 0 to 360 degrees. Now, let me use this XY axis to help us understand some things first. This is our positive X. That's our positive Y, the negative X, and the negative Y. On a compass rose that is set up like this, we would generally specify the positive X direction to be east. The positive Y would be north. The negative X would be west, and the negative Y would be south. I can't tell you how many times I have seen kids, I give them the direction west, but they draw it to the right. Or I give them the direction east, but they draw it pointing left. That's not correct. You need to know which way those directions point. Let's take your break, and when we come back, we'll deal with the angle measures, which are the tricky ones. Put the foot down on the door, otherwise it will lock you out. See, Chen, when did you test out for your ELL? Now you're a senior. Do you know, are you still entitled? Last year you were entitled to time and half because of your ELL status, right?
I don't take extra time.
Okay, all right. Because if you were, I was like, when are we going to figure out that extra 20 minutes for yourself? All right, good.
But sometimes, like in the exam, like in term or region, I do the exam
Translation.
the book. That would be
The dictionary.
yes.
Okay. You can also, what's your name in Chinese? You can order the exam in Chinese. I don't know if it would though, because then I don't know what the physics words they would translate. I want you to think about that. We would need to know in January. I think we can get it in Chinese. You're welcome. I know they do certain translations. I don't know. Certain exams are translated. I think physics is one of them, but I'm not 100% sure. We've never ordered the translation before, so
Yeah, I had them for only in
social studies translated for you.
but last time I took from region and cheap.
Okay. Do you have a dictionary that you use?
I do.
You can bring it to the test tomorrow if you want. Okay. All right, let's continue. And now I want to talk to you about angle measures. How do we measure angles on here in degrees? All the angles we will always quote are positive angle measures. And what that means when we measure an angle, so angle measures, there's two rules on how we measure. You always start at the positive x-axis. You always start at the positive x-axis. And you're going to rotate around the origin. Gentlemen. You're going to rotate around the origin going counterclockwise to measure your angle. Counterclockwise, you'll see the abbreviation CCW sometimes when we're using that. Okay. So let's talk about the angles then on this XY coordinate system. Because we always start measuring angles at the positive x-axis, it means when I come back to this diagram that our positive x-axis is our reference line, which we will always assume, therefore, to be 0 degrees. Counterclockwise, here's the origin. We start here, we go counterclockwise around like that. That is counterclockwise, which means north would be 90 degrees. We continue going counterclockwise till we get west, which means west would be equivalent to 180 degrees. Continuing 90 degrees counterclockwise, we would get to south, which must therefore be 270 degrees. And then we continue back around till we get to the positive x, which gives us 360 degrees. Angle measures are therefore the most precise way to give a direction, because these words only refer to straight up and down or straight right and left kind of motion. But what if I'm here or there? Even though they are both in the northeasterly kind of way, northeast would point us exactly halfway between the north and the east. Neither of these is exactly halfway between. You're off from that. So the easiest way we often to make ourselves precise about an exact location is we give an angle measure. And that's where we use protractors. You will need your protractor in class on Thursday. Please make sure you have it here Thursday, because we'll be measuring and drawing things to scale with our protractor for exact locations of things. So angle measures are the most precise, and you would quote something like, if I were here and I measured with my protractor, that might be like 19 degrees. These have quadrants in mathematics that you should be familiar with. This is called quadrant 1. This is called quadrant 2. This is quadrant 3. And this is quadrant 4. We'll be using those when we do calculations in a few minutes. All right, so we've just talked about position, how it's a vector, how we specify direction. Let's now talk about a term, the next vocabulary term in our objectives for this lesson, which is the term displacement. What is a displacement? A displacement is defined as the change in the position of an object. It's the change in position. Because we're looking at changes in a vector measurement, it means that displacement is also a vector measurement. It is also a vector measurement, which means it's going to have both a magnitude, which is a synonym for size or amount, and it must also have a direction on it. Now, in physics, we symbolize displacement with a lowercase d, but to indicate it is a vector, we're going to put an arrow over the top of it. The arrow over the top of it will tell you that this is displacement. And in the metric system, the units of measure for displacements are meters, which we abbreviate with a lowercase m. So I'm going to go through 2 examples with you of how you would find a displacement, okay? Let's start with this positive x-axis, and let's say the origin is here. And this is going to have markings in meters. 1, 2, 3, 4, 5. Let's say the object starts here. I'm going to label that with an I, which means initial or starting position. And it ends here. I'm going to label that with an F. Guess what F stands for? Final, right? Final or ending position. So what I see from this, because I'm along the x-axis, that my initial x coordinate is positive 1 meter. Remember, the positive tells me I am to the right of the origin by 1 meter. And my final x coordinate is positive 5 meters. If I want the displacement, I need to look at the change in these positions. That means I take the final position and subtract the initial position from it. So that means in this example, I would take positive 5 meters and subtract positive 1 meters. What would that leave you with as an answer for the displacement? Thank you for putting the positive on there. A lot of times kids just say 4 meters, and that is not correct. It needs to be positive 4 meters. Why do I need that positive sign on there? Because displacement is a vector. It needs a direction. And since this is along the x-axis, that positive sign means that we moved to the right. So you would either say positive 4 meters or 4 meters to the right. You could specify it either way. That is the displacement in that problem. Now, let's try a more challenging one. Can I go on to the next page? Okay. So let's say that I have a location in 2 dimensions in the x and y axes. Let's say I start here. There's my origin. 1 meter, 1 meter, and I end up not quite that high up. Let's say that is 5 meters, and that is 4 meters. This is my initial position, and that is my final position. So if I were to do this like I was doing before, I would say my initial x coordinate was 1 meter, positive 1 meter. My final x coordinate is positive 5 meters. My initial y coordinate was positive 1 meter. And my final y coordinate is positive 4 meters. You with me so far? We're going to break this down into 2 steps. Can you tell me how far we were displaced in the x direction using these? This is just like the problem we had a moment ago, right? We started at positive 1 meter. We ended at positive 5 meters. What's the displacement in the x direction? You see, I put an x subscript after that. That tells me along the x-axis. How far were we displaced, Nathan? Yes, positive 4 meters. That means we ended up 4 meters to the right of where we started. Can you do the same thing in the y direction, please? How far was this object displaced in the y direction? Marne, can you tell me? Not 4, not 5. Remember, to get a displacement, you do the final value minus the initial value. And is it positive or negative? Yes, positive 3 meters. Now, in this case, that means 3 meters going up. This meant 4 meters going to the right. Okay, that's not going to be your final answer to the question. What we have to do is look at this as we moved this way 4 meters. See an arrow 4 meters to the right. And then we moved in that direction 3 meters going up. The actual displacement in this case is the hypotenuse of this triangle. What type of triangle did I draw? It's a right triangle, which means we should have a way to determine that hypotenuse. You know how you would get it? You're going to use Pythagorean theorem. In other words, we're going to use a squared plus b squared equals c squared. What we would translate that to with these sides of the triangle, it would be the horizontal displacement squared plus the vertical displacement squared equaling the actual displacement's magnitude squared. So I would plug in 4 meters squared plus 3 meters squared to give me the displacement squared. So what is the magnitude of that displacement? Some of you probably already know. It's a very famous Pythagorean triple. It's a 3, 4, 5 right triangle. So that displacement's magnitude is 5 meters. But you have to give me the direction on that. This is where things get tricky. Look at that triangle for a minute. Is that right? Is that displacement vector pointing right? No. Is it pointing up? No, it's something in between, which means that this is where we have to figure out the angle from the horizontal. That angle right there, which I'm going to label theta, is the direction that the displacement vector is pointing in. And we have to calculate that. So the way we do that, if we think about a right triangle, there's 3 sides. This is what we call the adjacent side to the right triangle. This is called the opposite side of the right triangle, and this is called the hypotenuse of the right triangle. When you took geometry, you learned of a phrase to help you remember the trig functions. Do you remember that phrase? SOHCAHTOA. Okay. Think about the 2 sides we know. We know the adjacent, which is A, and the opposite, which is O. When you think about SOHCAHTOA, which has the opposite and the adjacent in it? The TOA piece, where T stands for the tangent. That equation for the tangent of an angle is the opposite side length over the adjacent side length. For this triangle, that means that the tangent of the angle is the y displacement value over the x displacement value, because the opposite side is the y component and the adjacent side is the x side of the triangle, the horizontal side. Now we have to understand how we do the algebra to get the angle by itself. Anybody know how you undo the angle function on the left side of the equation to get it over to the right side? What's opposite of doing a tangent? Yeah, inverse tangent, or sometimes they call it arctangent. Do you know where that is on your calculator? This gets you the angle measure, not the tangent of the angle. Do you know where it is? Second tan. The way we write it is this way. You have to make sure you know how to write it correctly. That the angle we're looking for is the inverse tan, or tan to the -1 power, of the y over the x displacement. So in this problem, I'm going to bring that down here. The angle we are looking for would be the inverse tangent of 3 meters over 4 meters. Notice now the meters cancel out. So what I need you to check before you begin is the mode on your calculator. Go into your mode. And you want to make sure you're in the degree mode. So for your graphing calculator, hit the mode button and make sure it says DEG. When I do my regular calculator like this, I just hit the DRG key and it's underlined degrees. It says degrees here. That's important because when you take your midterm and your final, which is the regents for this class, we clear your calculator memory before the test and it goes to radians. You have to know to put it in degrees. So you'll have to know to go to the mode. We'll remind you to do it. I can't put it there for you. I can't touch your calculator. You have to do it. Okay. So now how do we type this in? So let's all do this together. It's the same on either calculator. See, there's my tan key. There's my inverse tan. So we're going to do second tan, 3 divided by 4. Close the parenthesis, hit enter. And there's the angle measure. We don't write that whole thing out. All the angles get rounded to the nearest degree, to the ones place. So what are you going to round that angle to? 37 degrees. So the angle in this question is 37 degrees, which happens to be in the first quadrant. So our final answer for the displacement in this problem would be 5 meters, comma, 37 degrees. That's how we write these answers, with the magnitude and then the direction. And 37 degrees is in the first quadrant, so that makes sense. This is pointing up and right in the first quadrant where x and y values are both positive. Okay, any questions on that? Don't worry, I'm going to give you a lot of these to practice as we go on. All right, but that's an example of displacement. The final term I need to talk to you about is the term distance. Distance is so much easier to do. It refers to how far an object has traveled. Total. How far did an object travel? Total. Now, the type of measurement that distance is classified as is a scalar measurement. What does that mean that it is a scalar? It's not a vector. Scalar measurements only have magnitude or size. They do not have a direction. No direction on them. No direction on things that are scalars. So the symbol that we're going to use for distance is just D without the arrow. Distance and displacement both start with D. That's why we use it. We distinguish between them by putting an arrow over the one that's the vector and no arrow over the one that's a scalar. And just like displacement, the units of distance are going to be, in the metric system, the units are meters, which we abbreviate with a lowercase m. So let's look at an example of that. Let's just do along the positive x-axis again. Let's say you start here at the origin. You go this way, you end up at the 5 meter mark, and then you turn around and you come back and you end up at the 3 meter mark. If I want to know the distance, all I do is I take the lengths of those arrows and I add them up. So the first arrow would be 5 meters. The second arrow from 5 to 3 would be 2 meters, which means the total distance I traveled was 7 meters. That's the distance. Let's see if you can tell me what is the displacement of this. To do the displacement, you just look at the starting and ending positions. That's it. My starting position is 0 meters. My ending position is here. This is the initial, and that is the final, which means I'm going to take positive 3 meters because I ended up 3 meters to the right of the origin, and I subtract the origin, 0 meters from it, which means my displacement is positive 3 meters or 3 meters to the right. I ended up 3 meters to the right of where I started. Notice my distance and displacement magnitudes are not equal. 7 does not equal 3. Okay. Any questions on this? All right, I want to quiz you. Nikki? Because I just look at my very beginning and my very end point. I don't care what I did in the middle. That's why this 5 meter doesn't come into play, because I started here, I walked here, and then I backtracked. So I end here, which is 3 meters to the right of the origin. Yeah, you just look at the start and ending points. That's it. Okay. All right, so I'm going to give you some examples. I want you to tell me whether it's a distance or a displacement value that I'm giving you. Let's start with 2 meters. Is that a distance or a displacement measurement? That's a distance. How do you know? No direction on it. Very good. How about positive 2 meters? What is that? That's a displacement. How do you know, Colin? Yeah, it's got a direction, the positive sign. How about 4 meters north? Displacement. How do you know? Got a direction. How about 5 meters at 125 degrees? That's a displacement. How do you know? It's got a direction, the angle. Okay. All right. That's it for notes right now. We're going to go to our packet and try some practice. So please turn to page 1 of Unit 2's packet. Actually, I lied. Turn to page 3. Pages 1 and 2 are the homework that is due on Thursday, along with watching the videos. There's 2 videos to watch for Thursday on distance, displacement, and position. And we're going to start with the questions on page 3. You might need a calculator. Oh, before I forget, reference table. Please turn to page 6. Kinematics is part of the larger branch of physics known as mechanics. And the letter that we learned today was the lowercase d. Please check that off. As we learn things, we'll check them off. We said these are always going to be measured in meters. And displacements are vectors. So I'm going to put an arrow over the word displacement to remind me that that's the vector, where distance is the scalar. Okay? Just as a reminder. Most of these example problems that we're going to look at on pages 3 and 4, we have to make sketches for them to help us solve. So let's look at question number 1. It says that we have a cart that rolls 2 meters to the right and then goes back a meter to the left. So if I were to sketch that out with arrows, I would show it going 2 meters to the right and then it moves back 1 meter. Okay, that would be a sketch showing what the cart did. It went 2 meters to the right and then another arrow coming back 1 meter. So the first asks, what's the total distance? That's D without the arrow. How am I going to get that? Zichang, can you tell me how I'm going to calculate that out? What am I going to do? No equation. What do I do with these numbers to come up with my answer? not minus.
Oh, plus.
Plus, there you go, plus 1 meter. And so, Jalila, what does that mean the distance traveled is? 3 meters. Okay, so this cart moved a total distance of 3 meters. Now, part B wants to know the displacement. What we're going to do with each of these arrows is now put a direction on them. 2 meters. Mariah, is that positive or negative? Okay, so we're going to take positive 2 meters, and we're going to add that to the 1 meter, but is the 1 meter, Ayana, is that 1 meter positive or negative? It's negative, that's right, because it points left. So when I add those together, Bryce, what do I get? I agree that the value is 1, but what is it missing because it's displayed? Plus 1 or 1 meter to the right. There we go. Don't forget the direction on it. Yep, Shane? No, you give me one or the other. The answer I prefer is the 1 meter right, because eventually we're going to see things going up and down as well. And positive, you mean up, not right. Okay, let's look at number 2. We have a child observing a caterpillar that's walking on a windowsill. The caterpillar goes 18 centimeters to the left, then 6 centimeters to the right, and then 10 centimeters to the left. Let's sketch that out. So it starts off going 18 centimeters left. Then it goes 6 centimeters to the right. I'm kind of like stacking these arrows on top of each other. And then it's going to turn and go another 10 centimeters to the left. Please make that 10 point centimeters, by the way. We're doing everything to the ones place here. Okay, first thing I want to know is the distance, D. Dan, what am I going to do to come up with the distance? Okay, so that's 18 cm plus 6 cm plus 10 point cm. All right, so let's add those up. You have your calculator so you can do the math. Lila, can you tell me what you get for that distance? I'm sorry? There you go. 34 centimeters is correct. Okay, now I want the displacement. That's D with the arrow. So we're going to do the same thing, but we're going to put signs on all those numbers. 18 centimeters is left. Hudson, what sign do I use with left? Negative. That's right. So negative 18 cm plus, now what sign am I going to put on the 6 centimeters, Nathan? Yep, because that's to the right. Muhammad, what am I going to put on the 10 point centimeters? Yep, negative 10 point centimeters. All right, let's add those up. Mia, can you tell me what that means the displacement is? Yep, or 22 cm to the left. That's right. We're going to put both in our notes because this is going to help you with problems later on. All right, number 3 is a little different. We have a ball that we're going to throw upward starting at an initial height of 1.5 meters above the ground. The ball is going to go up to a height of 5 meters and then it will fall to the ground. All right, so let's make a little picture of what this is doing. This is the ground. When we draw a horizontal line like that with all these hash marks underneath, that refers to the ground. Where are we starting? We're starting 1.5 meters above the ground. That is the initial position, which happens to be 1.5 meters. The ball is going to go up and get to this high point, which is a total of 3.5 meters above the ground. And then it's going to continue back down until it lands on the ground. So it's like it went up and then it comes down, right? That's what it just did. So let's start by figuring out the distance traveled by the ball. Brody, can you tell me what I need to add together to figure out the distance? Okay, it starts here. How far is it from here to here? Nope. From the ground to here's 5. There you go. So we're going to take 3.5 meters and add it to what? There you go. So Marnay, can you tell me what the total distance traveled is? Yeah. Let's make that 5.0 meters, by the way. Okay. So that way we can keep the precision. Now I want the displacement. That's D with the arrow. What are we going to do to these numbers to figure out the displacement? We're going to put signs on them. Nicole, can you tell me what sign I'm going to put on the 3.5 meters? Yeah, because that's up. Up is a positive direction. And what sign am I going to put on the 5.0 meters? I want to say Liam. Is that right? Logan. What sign am I going to put on the 5.0 meters to figure out the displacement? Negative, right? Because it's going down. So what does that mean, Joshua, the displacement is? You can use your calculator if you want. Positive 3.5 plus negative 5.0. No. Eric, what do you get? Negative 1.5 meters or 1.5 meters going down. Not south. It didn't go to Florida. That would be south. Okay. Down is towards the ground, not towards Florida. Okay. Bryce, you had a question.
Oh, yeah. Like in the parentheses, could you put like 3.5 meters up?
Yeah, it's a lot harder to type that into your calculator though. Right. So I'm trying to write it in a way that you can then go right to your calculator to get an answer. But yes, you are correct. You could have said 3.5 meters up added to 5.0 meters down. It's the same thing. It's just harder to type it in your calculator that way. Okay, let's look at number 4. The path from the subway station to the art museum is 3 blocks to the north and then 4 blocks to the west. I want to know what is the straight line distance in blocks from the subway station to the art museum. And they give you a little diagram so we can kind of sketch this out. So let's do this together. Let's say that right here, that dot is the subway station. Now let's map this out. We got to go 3 blocks north. North would be up on the page. 1, 2, 3 blocks. So that arrow right there represents 3 blocks going north. And now we have to go 4 blocks west from here. 1, 2, 3, 4. So that arrow is 4 blocks west, which we abbreviate west with a capital W. The straight line distance would be, oh, and let me label that point. What is it there? That's the art museum. That's where the art museum is. I want to know that straight line distance. That would be what we call the magnitude of our displacement. Any idea how we're going to get it? Nikki? That's right. A squared plus B squared equals C squared. So I'm just going to say 3 blocks squared plus 4 blocks squared is equal to that displacement's magnitude squared. So without the square, what is that displacement? I think we did these numbers a few minutes ago, right? So Josiah, can you tell me what the displacement's magnitude is? 5 what? Blocks. That's correct. Good. 5 blocks. Here, you don't need to come up with the direction because it said distance. There's no direction on that. Just how far are those 2 points apart? Okay. Doing okay? Yeah. Because we're still traveling that amount, but they want to know the straight line from here to here. So how far are those 2 apart? Straight line distance is going directly from here to there. So the only way you can get it. Yeah, you're not adding 3 to 4 because those are not in a straight line. They're perpendicular. What? It would be the same as what we did in our packet, except this is 36 degrees or 37 degrees beyond north. North is 90, so it would be 90 plus 37, which is 127 degrees. This is pointing in the northwest direction. We'll get to some of those once we get to page 5 in our packet on Thursday. Okay? All right, so folks, your homework for tomorrow is to study for your test. Bringing pen, pencil, ruler, calculator with you tomorrow. But then for Thursday, you do have a written assignment in this packet, watching a couple of videos and completing pages 1 and 2. All right? Please complete pages 1 and 2 in your packet for Thursday.